All right, so we finished the unit on quadratic functions, which we will be testing on Monday. And quadratic function is the whole curve, right? And you think about what we were interested in with a quadratic function, right? Like, where's the vertex and maximum and minimum, right? Which is all dealing with the vertex. So in a quadratic function, we're interested in the curve, right? What does the y-intercept mean? What does the x-intercept mean? What are the x-intercepts? How do we determine them? Oh, look, algebraically determine the x-intercepts. And that's really what a quadratic equation is. What are the x-intercepts, right? Like, what is the solution? So an equation is, it's equal to something, right? Whereas the function is y equals, right? Which is every point on that, or a subset of the domain if we're looking at a particular example. Like, you've got a parabolic arch, or the cables for a suspension bridge are in the shape of a parabola. Only when you put weight on them, they're actually a catenary when there's no weight, but that's beyond the scope. Anyways, algebraically determine the x-intercepts. So the x-intercepts, what do we know about them? We know that y is equal to 0, right? So for the x-intercepts, we know that y is 0, so we will set y to 0 and go to x minus 3 squared minus 8. And we're going to solve that, so first step would be to do what? Get rid of the 8, right? We're going to do that by adding 8 to both sides. So this is something you might have to do for the test, right? I mean, it's a legit question for a quadratic function. And next step, we're going to divide by 2. Okay, so the idea is we want to isolate the thing that's squared, because we can unsquare it. So how do you unsquare something? You take its square root. What's the square root of 4?
Negative and positive.
Yeah, plus or minus 2, right? Because we know, I mean, what do we know about this thing? Well, we know it opens which way? It opens up, its vertex is at 3, negative 8. So if it opens up, then it has how many x-intercepts? There's going to be 2 of them. So when I get down to this point here, where we're going to actually say, what are the values of x? We can't just write 2, right? It's plus or minus 2. Is equal to x minus 3. And then, you're welcome, what's x equal to?
3 plus or minus 8.
Right, so x is equal to 3 plus or minus 2, which is going to give us 2 values, right? So we can then say, well, x is equal to 3 plus 2, which is 5, and x is equal to 3 minus 2, which is 1. Now, we could have found these using other methods, right? We didn't have to do this algebraically. We know what the vertex is. We know what the stretch factor is. We know which way it opens. We could have sketched that, right? We could have said, oh, okay, look, and once I found one of them, when I know that one of them is 5, so I know what's the axis of symmetry for this thing? What's the equation of the axis of symmetry? X equals 3, right? So if you're asked for axis of symmetry, you write down 3, I write down 0. Yeah, no, that's not quite it, right? It's an equation, right? So it's the line, right? It's the vertical line, the line x equals 3, right? So if I know that one of the x-intercepts is at 5, then I know the other one has to be at 1, right? Because you go 2 to the right of the axis of symmetry, 2 to the left. Verify your answers by substitution. Okay, so we now think that the answers are 5, so I have an x value of 5. So I'm saying 0 is equal to 2 times 5 minus 3 squared minus 8. So 0 is equal to 2 times 2 squared minus 8, which is, I don't know how much detail we want, 2 times 4 minus 8. 0 is equal to 8 minus 8, and 0 equals 0. So that's a check, right? Works out. True statement, right? That's what we're looking for, is a true statement. And then verify your answers. You can't just verify one. Okay, you must verify them both. So 0 is equal to 2 times 1 minus 3 quantity squared minus 8. This is negative 2 quantity squared. Negative 2 squared is 4. And that also checks. Okay. So verifying answers by substitution. Right. And not a bad idea, right? Like, I mean, on a test or that, when you've gone through the test and you're going back over it, you know, you can redo questions and just try and make sure you can verify. You know, can I check this out? Sure. Yeah, I can verify this. All right, so to determine the x-intercepts of the quadratic function, y equals ax squared plus bx plus c, we must substitute y equals 0. And then solve the corresponding quadratic equation, right? So function y equals, that's all of the points, right? That's the entire curve. The equation 0 equals ax squared plus bx plus c. That's only true for, at most, how many values? 2. Could be 1, or it could be none. There may be no solution, right? We know that if this thing opens up and its vertex is above the x-axis, that there will be no solution to that equation, right? There's no way, there's no value of x that can make it 0. The solutions to an equation are called the roots of the equation. Okay, so the solutions are called the roots of the equation. Therefore, the x-intercepts of the quadratic function, y equals ax squared plus bx plus c, are the same as the roots of the corresponding quadratic equation, which is 0 is equal to ax squared plus bx plus c. Since these same values of x make the function equal to 0, they are also called the zeros of the quadratic function. Okay, so we've got 3 ways that we can talk about these things. Get rid of that. The x-intercept of a graph, the x-coordinate of a point where the graph intersects the x-axis, the 0 of a function, the value of x that makes the function equal to 0, or the root of an equation, which is a solution to an equation. Okay, so there's just 3 ways. We're not going to test you, so we're going to ask you questions saying, what are these called? Are these the, you know, but they're the x-intercepts of the graph, right? So you think about the graph. I've drawn this whole thing. Where I intercept the x-axis, it's the x-intercepts. It's the 0 of the function, okay? Because remember, this is the function. So the 0 is when you replace y with 0. And it's the roots of an equation. And the roots are the solutions to the equation. Okay. So therefore, the x-intercepts of the function y equals ax squared plus bx plus c are the same as the zeros of the function y equals ax squared plus bx plus c are the same as the roots of the equation. 0 is equal to ax squared plus bx plus c. Since a quadratic function may have 2, 1, or no x-intercepts, see, I mean, you say, oh, the test is the day and we're doing something new, and yeah, but not much, right? This, you still have to know all this stuff for the test, right? It's about the function. So there we go, 2 x-intercepts, 2 zeros, 2 real roots. What's going on here? We know that the a value is, so we say greater than 0, and we know the q value is, so if a is greater than 0, it opens up, and q is less than 0, then it's been moved down, then there will be 2 x-intercepts. Okay, in this one, the a value is positive. Q is
0.
okay, so if we open up, now we could open down, right? This wouldn't matter, right? If Q is 0, then you're not moved up or down. There may be a left or right movement, but there will be 1 x-intercept, right? And here, a is greater than 0 and Q is greater than 0. Okay. We could also have a is less than 0, Q is less than 0. I mean, this isn't the definitive, right? But this is showing you possibilities. So 2x-intercepts, or 2 zeros, or 2 real roots. 1 x-intercept, 1 zero, 1 real root. No x-intercepts, no zeros, no real roots, right? No solutions to the equation. A quadratic equation is an equation that can be expressed in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. We will learn to solve quadratic equations by graphing the corresponding function, y equals ax squared plus bx plus c, and finding the x-intercepts. We've done a little of that already. Factoring ax squared plus bx plus c and using the 0 property. Completing the square and using the square root principle. Okay, so we know how to complete the square, right? But we're going to take that one step further to solve. And using the quadratic equation, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Which is very easy to memorize if you sing it to the tune of Pop Goes the Weasel. Which I won't do for you. At least not now, but when we actually learn it. Make a little more sense. You'll never forget it. You just walk in here humming the tune.
Would that be on our formula sheet? If we get one.
No, just say hum the tune to Pop Goes the Weasel. Yeah, it'll be on your formula sheet. It's even on the formula sheet in Math 30-1, right? Because it may be necessary to solve a thing. And use formula sheets when you have them. Don't use your memory necessarily, right? Because that may be faulty. Solve a quadratic equation by graphing the corresponding quadratic function. Okay, so that's what today was, right? So what is this quadratic equation thing and the roots and all that, and how are we going to solve by graphing? Since the roots of the quadratic equation, ax squared plus bx plus c equals 0, are the same as the x-intercepts of the corresponding quadratic function, y equals ax squared plus bx plus c, we can solve the equation by graphing the corresponding function and finding the x-intercepts. Solve by graphing, round answers to nearest hundredth where necessary. Okay, so here's what we're going to do. Now, your clue that you can use graphing is, first of all, it will not say algebraically determined. So sometimes we say algebraically determined, right, which means that you have to show an algebraic method. So all the other ones that were described, the quadratic formula, the completing the square, the factoring, and all of that. That's all stuff we're definitely going to practice. But today we want to graph. So, calculator's out. Turn on. Go to y equals. So we're going to enter the first 3x squared minus 8x plus 5. 3x squared minus 8x plus 5. And in y2, we're going to graph 0. Okay, so I'm going to draw the two lines. And the reason I do that is I like the intercept function on the calculator better than I like the zeros, right? There is the function for zeros. And we'll do it both ways, just so you can see both ways. But here's what we're doing. So we should be explaining, right? y1 equals 3x squared minus 8x plus 5. y2 is equal to 0. Okay, I'm going to just hit graph. I'm going to let it graph it on the default grid, and the default grid is negative 10 to 10 and negative 10 to 10. And I can see that, oh, it's nice color, right? Color one's nice because I can actually see this if you're using a black and white one. And I can see that, I want to look a little closer at this region here, right? Because that's where the zeros are, and they're kind of tucked together. So let's adjust our window. And say, well, let's go for, this looks like about what, 1? So let's go maybe 0 to 3, and let's go from, say, negative 1 to whatever, let's say. So let's go from 0 to 3 for my x's. Didn't get a 3 out of that. 3. And the x scale, I'm just going to leave it 1. I mean, it doesn't matter. Let's go from negative 1 to, oh, let's say 2. Whoops. Negative 1 to 2. Also by 1s. And hit graph. And there we go. So, we got a little better view right, of what's going on. We're a little tighter in. Okay, so first method, I'm going to show you using zeros. Okay, using the zero on the calculator. So second function, calc. Number 2 is the 0. Now what it asks for is a left boundary. So it says you need to have the cursor placed somewhere to the left of this 0, right? Remember 0 is the solution. So I'm just going to move. Okay, good enough, right? It's to the left of the 0. And I hit enter. Now yours may just put a little thing up here, a little triangle up there to show you. And then I need to go, it says right boundary. Now what I need to do is I need to go so that I've gone through the 0, which means the left boundary for this guy has to be positive and the right boundary has to be negative. Hit enter. Then it wants a guess, because there are 2 zeros here, but it's basically saying I'm going to look somewhere between here and here. Okay, so I'm just going to move till it's about at the 0, okay, and hit enter. And we say, oh, there it is. The 0 occurs when x equals 1. Right? And that's what we want. The solution is not the y value, right? We know the y value is 0. We want the x value. What's x equal to? Okay, it says round answers to the nearest hundredth. This one is exact, but x equals 1, or I guess we could write 1.00. Okay, well, it says where necessary, okay? Not necessary, right? X equals 1. Just is what it is. Okay, to get the second 0, we repeat. So second function, calc. Again, I'm not using the intersect. I'm just using the 0 function. That's number 2. Left boundary. Now, in this case, the left boundary has to be below, so it's going to have to be a negative y value. Okay, enter. Right bound. Whoa, stop.
What's happening?
Enter. Yeah, it's like it locked on.
Oh God, you're going so far. Oh, you're going too far.
Kill. Actually, wait. If I hit on, that should stop it.
No,
It's
it's not stopping it.
No. Something's jammed. Okay. Boom. Dead. Okay. I'm gonna bring it back. Graph. Alright, I'm just gonna do this one on here. So second calc 0. I need left boundary. So I just need to make sure it's negative there. It's negative. I need a right boundary. It's positive. I need a guess. Enter. 1.666666. So what's x equal to?
1.67.
1.67 rounded to the nearest hundredth. So watch your rounding. Right? Watch your rounding. All right. So I'll do that. We'll do the other one. We'll do the intersect on the other one. Okay. So that's using the zeros, right? You need a left bound, you need a right bound, you need a guess. This needs to be rearranged. Okay, needs to be written as ax squared plus bx plus c equals 0. So I need to move the 9x and the 4 over. So it becomes 2x squared minus 9x minus 4 is equal to 0. Okay, so I'm going to graph y1 is 2x squared minus 9x minus 4. And I'm going to graph y2 as 0. And this time we'll solve using intercepts. Okay. So let's go back to y equals. I could clear this out or I can edit it in place. So 2x squared minus 9x minus 4. Okay, so there's the first one, and y2 equals 0. I'm going to hit graph to see, okay, what does this look like?
A line.
Okay, so what you might want to do is hit zoom standard, right? So you can go zoom standard. If we were using this to have to find the vertex, right, min or max, we would have to extend the window down, right? So that's something you might have to do on Monday for the test. You know, what are the coordinates of the vertex? You say, hey, I can just graph that, right? It's a multiple choice question. I don't have to show work, so I can graph that. To find this particular vertex, you'd have to adjust your window. So here, now I'm going to use intersect. So second calc and number 5 is intersect. So I have 2 lines drawn. So all I'm going to do is just move to about the point of intersection that I want. So that's close enough. Now it says first curve, and you notice it's on y1, it's on the 2x squared, so I hit enter. It says second curve, and now it jumps up to the line y equals 0, so I hit enter. And it asks for a guess, and I'm as close as I could get, so I'm just going to hit enter. And we get negative 0.4 what? Negative 0.41. So that's our first one. Okay. Now what I like about this is I don't have to worry about left bound, right bound. So now I'm going to do it again. Second calc, intersect. Now you notice it's on y1, but I want to get over here. If I trace y1, I'm going to have to go all the way down and back up again. So I'm just going to push the down arrow and go to y2. And now, when I hit the right arrow, it's either going to jam on and then we'll have to cut. So I'm just going to do this very carefully. Then I'm just moving along the straight line, right? Which is going to be the faster way to get there, and you won't have these problems. Where'd it go?
I think you went to the
Oh, I went to the other curve. Okay, yeah. So I moved to about the point of intersection. 1, 2, 3 times on enter. 4 point what? Well, okay. First, let's get the x, then we'll talk about the y. So what's x? 4.91. Okay, do you know scientific notation?
Yes.
Okay, 1e negative 12 is 1 times 10 to the negative 12, which is really close to what? 0. So your calculator, right, I mean, it can't always find a nice 0, right? It did for the x equals 1 over here, because that was exact, right? When x was 1, this really is 0. But here it's just saying this is as close as I can come to 0, which is 0.000000000001. Okay, that's 0. Okay, and same deal. Sometimes you might see over here, you might see 1.00000001. You take that as being exactly 1. Okay, and again, just because it's using electronic methods to calculate these, it's not using algebraic methods. So it's not exact, and we are to the nearest hundredth. Okay, so you have 2 things, right? I don't care which one you use. Whether you do the zeros, left bound, right bound, guess, or you do the intersect, in which case you're graphing y2. Either one works. Okay, what do we got? 2 more examples. The path of a golf ball can be modified by the function h of d is equal to negative 0.002 d squared plus 0.4 d, where h is the height in feet and d is the horizontal distance traveled in feet. What is the maximum height reached by the golf ball? Yeah, that's some Monday's test kind of question, right? Like, see, we're actually reviewing for the test. So, what do we have to do here? Well, how does it say to do it? Does it say algebraically determine?
No. It just says what it is.
So what's an easy way to do this?
Put it in your calculator.
Graph it. Yeah. Besides, what's it say at the top of the page? Solving by graphing. All right, so save yourself some grief. Okay, what do we got? Negative. Scooch this up a touch. So y equals negative. That's the That's this down here, right? That's subtraction. This is the make it negative. 0.002. Now we don't have a d, right? So we have to use x. X squared plus 0.4x. Now we might want to think about this. This is a golf ball height. If I just try and graph this on the standard grid, we might say, well, yeah, okay, it really looks like a straight line, kind of. So, all right, let's get reasonable. Let's set a window. So we're going to start at 0, right? Doesn't make any sense. Horizontal distance. How far can a golf ball usually fly? What can guys hit a golf ball?
350 yards.
So 350 yards. So we could go. Let's start with. Yeah, we don't know how good this golfer is. So 350 yards would be like 1,000 feet. So I'm going to go with like 500 feet. Okay, because the x's are the horizontal distance, right? Not the time. And then how high is this thing? Well, next scale, we don't want 1, so I would say maybe by 50s. Now the y min, 0, right? Y max. So how high do we think this thing might go? No idea, right? I'm going to say 100. Okay, 100. And let's go by 10. All right, yeah, you're right. Didn't get hit very far, right? So how far? What do we say? 50, 100, 150, like 200 feet. Okay, and how high did this go? 10, like 20. So it's kind of like a shot that I would hit. Okay, so we can readjust the window. So say, all right, 0 to 200 by 10s. And how high do we say it went? Like about 20 feet or something. So let's go 0 to maybe 25. 5s. Okay. And all right. Nice, eh? That's a lot better, right? I mean, the more we can fill this, the easier it is for us to be able to work with it, you know, as opposed to, and you know, it's a scale of what we call iterative refinement, right? You try a couple of numbers. I mean, one thing you can do actually, if you want to get a clue, so what values should I be looking at? Go into the table. It's all right, so 0, you know, 3. Now you have to scroll down a whole bunch, right? So, you know, table might not be the best solution here. But you just play with the numbers on the graph until you come up with something, right? And what did we want? What did we want? The maximum. I forgot what we were doing. Okay, second calc, I want the maximum. That's number 4. Okay, now it's actually, I think it's pretty much at the maximum there, but so left bound, we just have to move a little bit to the left of the maximum, and right bound, move to the right of the maximum, and it wants a guess, so you just go like close. Okay, 100.00002, we're going to call that 100, right? Again, that's another example of your calculator actually rounding, right? I think if we plugged in 20, we might just get exactly 100. I'm not entirely sure. So what is maximum height reached by the ball? 100 feet. Okay, so we y1 is negative 0.002 x squared plus 0.4x. Graph and use calculator.
So that kind of showed you where that was.
Yeah. So you just I graphed to use calculator to determine maximum. And the maximum height is 100 feet.
Wouldn't it be
Is that a distance?
the y value?
Oh, sorry, yeah, it's the y value. Maximum height is 20 feet. Don't forget units, right? Don't forget arrows, right? We want arrows on graph, we want units. Check that over before you hand it in, right? If you walk up, hand it in, and you've lost like 2 marks because of arrows and units, that's just really kind of sad. You know, especially when it's like 20 minutes early and you could have just sat down and gone through and checked stuff over. What's the horizontal distance of the ball from the golfer when the ball reaches its maximum height? 100 feet. What distance does the ball travel horizontally until it first hits the ground? Okay, so what do we need to find now? We need to find this, right? So we can go to y equals. We can graph y2 equals 0. We might want to change the window a bit. I might want to go a little beyond 200 because, so let's say 225 maybe. And I might want to take my y min down to like minus 10. And the reason I'm doing that is just so we can see the 0 cleanly, right? We know what it is. It's 200, right? But second, calc. Come on. Calc. On 0, no, I'm going to do an intersect, right? Because I set that. I'm going to move down to the straight line because it's less, it's easier to just move across the straight line. We know it's 200. Okay, 1, 2, 3, 200. Okay, so 200 feet. Okay, don't forget units. Any questions on that one? Right, just graphed it, found the max. Manager of a store is investigating the effect that raising or lowering dress prices has on the daily revenue. We've done those, right? Revenue questions, okay? So many revenue questions, so little time. Remember, Monday, first period in 302, right? Or 103. Not much in there.
Oh no, you're not going to get yourself.
Yeah, it's not. The function r of x is 100 plus 15x minus x squared gives the store's change in revenue in dollars from dress sales, where x is the price change in dollars. Determine the price change that will result in no change in revenue. Okay, so we want no change in revenue, which means we want r of x to be what? 0. Okay, so we're going to graph this. We're going to look for the value of revenue to be 0. Okay, so graph y1 is 100 plus 15x minus x squared. And what do we want? And we want determine where, or use the graph to get the x values. Say value or values where y equals 0. Okay, let's go to y equals. I covered it up, but I'll just enter it. What is it? 100. So I'm going to clear this, right? It's easier to clear. So we got 100 plus. Now you could just enter the equation exactly as it sits, right? Now if it had been a revenue equation in brackets, you could just enter bracket, 100 minus 2x, bracket, 5 minus x, or whatever it is. Okay. Your calculator can do some math for you. So 100 plus 15x minus x squared, Okay, and I'm just going to go zoom standard because I have no idea what this thing looks like.
Pretty big.
But it kind of goes way up somewhere, and it's not coming down. So it's not coming down where this value is 10, right? It's going to be more than 10. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We've got like -5. Now is that a valid solution here? I guess so let's adjust our window. So I'm going to go into the table and just say, where do I need to look for the other value of 0, right? Because these guys are going up. So I'm just going to scroll down here and say, how far do we have to go? Because it's coming back down now, so how far do I have to go to get to 0? We're getting close. 20, okay. So, window, and how high did we go? About 150-ish or something? Okay, so let's go -10 out to, say, 25 by 5s, maybe. And y min, let's leave it at -10, just because I want to see the zeros, right? And graphing this, and how high do we go? Let's say 160 maybe by 10s. And let's see if we get a nice. That kind of works, right? Okay. So we're going to have no change in revenue at -5, and then, was this by 5? So 0, 5, 10, 15, 20. At -5 and 20. Okay. Now what you might want to do when you say you're graphing that is put down the window that you used. Okay, so the way we indicate a window is -10 to 25 by 5s. And the Y window was negative 10 to 160 by 10s. Okay. And we can sketch the graph, which we probably should have done on the last question. We didn't do that, did we? So we probably should have sketched this, right? And this was. So yeah, if you're going to do a graphical solution, you should show the graph, right? So sorry, that should have been done. And this was horizontal distance, and this was height. Okay. So should have shown that, but now we have. And this guy goes like this. So we've got -5 and 20. So what was X? Price change will result in no change in revenue. So if we decrease the price by $5, right, that -5 actually has meaning here. Okay, so say here, X equals -5, X equals 20. If we decrease the price, by $5, there will be no change in revenue. Or if we increase the price by $20, there will be no change. So in this case, it actually makes sense to deal with the negative x, right? With x as being negative. Say, well, x is -5. Yeah, that leads you to no change in revenue, as does x equals 20. So price change. Decrease it by $5 per dress or increase it by $20 per dress. You'll take in the same amount of revenue. Okay. Decreasing by 5, you'll sell more dresses, right? So that your revenue will stay the same. And increasing by 20, you'll sell fewer, but your revenue will stay the same. Okay, questions? So any home